Ever wondered how a tiny speck becomes a detailed image under a microscope? Well, it's all about the magic of magnification. Microscopes, our gateways to the microscopic world, work by using lenses to amplify details that would otherwise remain unseen by the naked eye. These remarkable tools are essential in various scientific fields and even in our everyday lives, helping us delve into the intricate details of the small. The world of the small becomes the world of the large under the lens of a microscope. First, we have the optical microscopes that use visible light and lenses to magnify images. This variety of microscope is perhaps the one most of us are familiar with, widely used in places such as schools and laboratories. But how does it work, you may ask? Well, it's a fascinating process. When you place a specimen under the microscope, light either passes through it or reflects off it. This light then travels through a series of lenses. Each lens bends the light to create a magnified image of the specimen. The final magnified image is what we see when we peer through the eyepiece. This process allows us to observe details that would otherwise remain hidden from the naked eye. From cells to minute organisms, the optical microscope has been instrumental in numerous scientific discoveries over the centuries. That's how an optical microscope brings the unseen world to our eyes. Next, we dive deeper with compound microscopes. These fascinating devices take the principles of magnification a step further by employing multiple lenses. The process begins as light passes through the specimen. This light then enters the objective lens, which is the first step in magnification. But we're not done there. This magnified image continues its journey through the eyepiece, undergoing further magnification. The result is an incredibly detailed view of our specimen. Compound microscopes, therefore, offer us an even closer look at the microscopic world. Finally, we journey into the atomic level with electron microscopes. These are not your average microscopes. Instead of light, they use a beam of electrons to illuminate the specimen. These electrons, having shorter wavelengths than light, allow for much higher magnification and resolution. Now let's dive into the two main types: transmission electron microscopes, or TEM, and scanning electron microscopes, or SEM. First up, the transmission electron microscope. Here, our beam of electrons doesn't reflect or scatter off the surface. No, it passes directly through the specimen. This beam then forms an image on a fluorescent screen or a digital detector. Think of it like looking through a window into the atomic world, observing the inner structures of a specimen. Next, we have the scanning electron microscope. This one works a little differently. Instead of passing through, the beam of electrons scans the surface of the specimen. As they interact with the atoms in the specimen, they produce signals that contain information about the specimen's surface and composition. This results in detailed three-dimensional images, giving us a topographical view of the specimen. So, from peering through the atomic window with the TEM to trekking over the atomic landscape with the SEM, electron microscopes offer us a fascinating way to explore the world at the smallest scales. And that's how electron microscopes allow us to explore the world at an atomic scale. From the optical to the electron, each microscope offers a unique window into the microscopic world. With the aid of visible light or a beam of electrons, these incredible devices magnify the minute details hidden from our naked eyes. The key lies in the magnification and resolution, allowing us to delve deeper into the mysteries of life's structures. Whether it's the simplicity of an optical microscope or the intricate functionality of an electron microscope, each has its own place in the realm of scientific exploration. Remember, the unseen world is just a microscope away.